Alright guys, so this is just a video on working through the review sheet. So if you're struggling with anything, you have the ability to watch it and get some help. So the directions say for 1 through 6 only factor, for 7 through 11 factor and solve. If I'm looking at number 1, I see that there's only 2 terms in here. That means most likely difference of squares. And in this case, both are perfect squares, so we can do difference of squares. So I'm going to square root the front, square root the back. Square root the front, you get 4x. The back you get 1. So then that's what we fill in our factors with. So it's going to be 4x plus 1 and 4x minus 1. And then those are our 2 factors. For number 2, we have 2 terms again. This time there's not a subtraction sign, so it can't be difference of squares though. Instead, what I see here is 5 comes out of this and 5 comes out of this, and then also n's would come out of both of these. So if we pulled a 5 and an n out, that would be the same thing as dividing each of these by 5n. So on the left side, we would have 9n left over, and on the right side, we would just have a positive 2. And then we look at this, can this factor any further? In this case, it can't. So then our answer would just be 5n times 9n plus 2. For number 3, we have just our standard quadratic. It's not anything special. So then I'm just going to pull out the factors of the back term, 1 and 20, 2 and 10, 5 and 4. I'm going to build my parentheses here. Things that are helping me, positive in the end tells me that they're going to match. Positive in the middle tells me that they're both going to be plus signs. So we have matching plus signs. 1 is on our x in the front, so it's just x and x. And then I need 2 terms that are going to add to 9. So in this case, 5 and 4 would add to 9. So then we're good. Number 4, so we have positive in the back, negative in the middle. So when I'm building my 2 sets of parentheses, it's going to be positive and negative. Just 1 for my a value, so it's n and n. My factors of 24, 1 and 24, 2 and 12, 3 and 7, 4 and 6. Those are all of the factors of 24. Oops, not 3 and 7. It's 3 and 8. So then we need 2 when added together is going to give us negative 11. Oh, what was I thinking? Positive means they're matching. They're both matching to negative. Sorry. So negative 3, negative 8 would give us that negative 11. Number 5, our a value is 1. We have negative and negative, which tells us negative at the back tells us positive and negative. So we have z and z. Factors of 40, 1 and 40, 2 and 20, 3, 4 and 10, 5 and 8. Looks like 5 and 8 could make negative 3. So if we went negative 8 and positive 5, that would give us our negative 3. For number 6 here, now we have an a value, right? So if we have an a value, we're going to have to split it up. It's a prime number, though, so we can go 5x and x, which is nice. Okay, prime number in the back means our only option is 1 and 3. We have negative 14, negative 3 at the end, so it's going to be plus and minus. Because it's a negative in the middle, I'm thinking we're going to want to multiply 5 by a negative number. That way we get pretty far in the negatives. And if I'm multiplying it in negative 14, I'm thinking 3, right? We need a pretty big negative number compared to our factors, so that would build us negative 15. That means the other side would have to be plus 1, so we just double check. Positive x, negative 15x, those 2 added together would in fact give us our negative 14. So then we can box in this answer, and then we're good to go. All right, now we moved into the solving questions, okay? So for solving, notice that it's set equal to 0. Those are the times you're going to solve. Whenever it's a quadratic set equal to something, those are going to be our solving questions. So for here, we have factors of 2 and 2, 1 and 4. In the back, we have 1 and 25, or 5 and 5. Those are our only options. Negative 20 in the middle is pretty big, so I'm leaning towards 1 and 4. Okay, and then it's not quite 1 and 25 big, so I'm kind of leaning towards 5 and 5 to go with 1 and 4. But let's see what happens. So if we're 1x, 4x, it has to be a positive and a negative. Again, multiplying -4 by negative would make sense because it's a negative in the middle. So we want a bigger negative number. So I'm going negative positive, and then we want negative 20. Well, if we did -4 times 5, we did -5, that gives us -20. So I guess maybe 4 and 1 might not work, right? Because that's going to be -20 and then 5x, right? So maybe that's not what we want. Maybe instead we want, gosh, what do we want here? 1 and 25, 25 on one side, 1 on the other would not work. So let's go maybe 2's. Oh, it's not. It's because it's not plus and minus. It's minus and minus. I don't know why I keep messing that up. Right, minus and minus because positive at the end tells us matching. Minus in the middle tells us that they're matching to minus. So minus and minus. So then, okay, back to the drawing board. 1 and 4. Do I want 1 and 4? Now I'm thinking I want 2x and 2x because now we're adding stuff together. We're not taking away anything. So if we go 2x and 2x, looks like 5's might work, right? So 2x and 5, 2x and 5, so that's 10x negative, 10x negative. Yeah, so it's good. And actually, check that out. That would be our perfect square trinomial, which makes sense. Perfect square here, perfect square here. So then 2x minus 5 squared would be our answer. So for number 8, let's look down at number 8. Oh, wait. Not our answer. I just said we need to solve this one. So we're solving it. Means we need to set that equal to 0. 2x minus 5 is equal to 0. Solve for x. Right, we would add the 5. 2x is equal to 5. Divide by 2. X is equal to 5 halves. And you don't need to write it twice. Just one time is good. All right. Now moving on to 4. Now moving on to 8. So if I'm looking at 8, I see 14 and 21. 7 comes out of both of those. X squared and x also comes out of both of those. So 7x, and then what's left over is 2x minus 3 is equal to 0. 7x is a factor. 2x minus 3 is a factor. Both of those need set equal to 0 to solve. So we get x equals 0 for one of our answers, and we get x equals positive 3 halves for our other answer. Number 9. Number 9, it looks like greatest common factor comes out, and it looks like it's 2. So we pull 2 out. That would give us 9x squared minus 3x minus 2 is equal to 0. So we have options here. 2 is going to stay. Actually, let's not let 2 stay. Let's divide that 2 off, make it a little bit more simplified. So that's 9x squared minus 3x minus 2 is equal to 0. Factors in the front are 1 and 3, or 1 and 9, 3 and 3, 1 and 2 in the back. If I'm looking at 1 and 9, we need -3 in the middle. I'm kind of leaning towards 3 and 3 because we have to work with 1 and 2, so I'm going to start there. So let's go 3x, 3x. It's negative in the back, so we're going to have a positive and a negative. Doesn't matter where we put them. Okay, so now we need to decide where's 1 going, where's 2 going. Well, 2 is probably going to go with negative because we're negative here. So that's -6, positive 3, so 3x, -6x would give us -3, so we're good. So 3x plus 1 is equal to 0, and 3x minus 2 is equal to 0, so that gives us x is equal to -1/3, and x is equal to positive 2/3. Number 10, let's switch colors. Number 10, it gives us a negative in the front. I don't like a negative in the front, but we can pull a greatest common factor out. So let's pull out the negative. So -2, if we pulled that out, would give us positive x squared, positive 2x, positive 1 is equal to 0. And then I'm just going to divide that -2 off to get rid of it. So we have x squared plus 2x plus 1 is equal to 0. Now we're factoring this to solve. This is a perfect square trinomial, I believe, right? Because perfect square in the front, perfect square in the back. If you take the square root, you get 1. Add it to itself, you get 2. So this should just be x plus 1, which means our factor would be x plus 1 squared. Set x plus 1 equal to 0. We would get x is equal to -1. Okay. Alrighty. number 11. So we need to first get everything to the same side so that it's set equal to 0. So I'm going to add the 5x squared. I'm also going to subtract off the 22. So 13 plus 5 is 18x squared plus 21x minus 22. Looking for a greatest common factor out of this. That's equal to 0. 22 is just 2. Can't pull out 22 out of 21. So 2 is not going to go for us here. Looks like we got to do some factoring. We have 1 and 22, 2 and 11. In the front we have 1 and 18, 2 and 9, 3 and 6 are all of our options. We're going to be mismatching signs and we need a positive in the middle. So where am I going to lean? I'm thinking 1 and 22 might be too big, so let's start with 2 and 11. I kind of like 2 and 11 with 3 and 6, so I'm going to start there. 3x, 6x, negative at the end, positive in the middle means plus and minus. I'm going to put the plus here, the minus here, right, because we want the bigger number to be positive. And then I said I was going to work with 2 and 11. Well, I guess if we went 11, 66 is probably too big here. So let's switch this. Let's go minus here and plus here. Let's put an 11 here, gives us 33. 2 gives us negative 12, so negative 12x, 33x, what does that give us? 33 minus 12, is that 21? Yeah, that's positive 21x. Okay, so it looks like this would be our factors. And then from here we can say 3x minus 2 equals 0, 6x plus 11 equals 0, and solve for x. X equals 2/3 on this side, and on the other side x equals negative 11/6. All right. Moving on to page number 2. So this next one says solve using square roots, write the answers in simplest radical form when it applies. So solving for square roots, we need to isolate all of the things on the square root, so we're going to subtract 5 from both sides. 3x squared is equal to 36. Divide by 3, we get x squared is equal to 12. And now we can square root both sides. When we square root both sides, remember that means a plus or minus is going to come out, so it's plus or minus radical 12. And then we need to simplify. Biggest perfect square that comes out of 12 is 4, so radical 4, radical 3, because 3 times 4 gives us 12. Radical 4 would become 2, so our answer for x is going to be plus or minus 2 radical 3. And then we're just going to continue on with this trend. So divide by negative 3 gives us x squared. Negative 213 divided by 3 is going to be 71. Square root both of these things, so x equals plus or minus the square root of 71. Man, does 71 have anything divisible by it? Not 2, 3. Nope, 71 divided by 4, probably not. 5, 6. 71. Doesn't look like it. 71 looks like it's going to be just how it is. Believe 71 is prime, so then that would be our answer. All right, next one. Isolate the square. So we're going to go 7x squared equals 35. Divide by 7. X squared is equal to 5. Square root both sides. X is equal to plus or minus the square root of 5. 5 is prime. Don't need to worry about pulling anything out of that. Next one, okay, now we have parentheses in here, so we need to get the parentheses by themselves. So now we have x minus 1 squared is equal to 2. Now we can take the square root of both sides, so x minus 1 is equal to plus or minus the square root of 2. And now we add the 1 to each side. This would give us x is equal to 1 plus or minus the square root of 2. And this is a perfectly acceptable answer. We don't need to switch it out. But we do need to realize that 1 plus or minus 2 is really 1 plus radical 2 and 1 minus radical 2. So if you don't realize that, I would split those up and write them out like that. 16, subtract 8, x squared over 20 is equal to 5 minus 8 is going to be 7. Multiply by 20. So that's going to be 140 is equal to x squared, square root both sides. X is equal to plus or minus 140. And now we got to pull some stuff out of here. So 140, let's think. Perfect square that's going to go into that. I know 4 probably for sure. Yeah, that's going to give us square root 4, square root 35. 35, can we pull a perfect square out of there? 1, 3, 5 would be 7. Nope, doesn't seem like it. So 2 and radical 35. So it looks like our answer is x equals plus or minus 2 radical 35. All right, last one. Solving anyway. So we're going to add 18 to both sides, and that's going to give us 7x minus 4 squared is equal to 28. Divide by 7 on both sides, so that's x minus 4 squared is equal to 28 divided by 7 would give us 4. Square root both sides, so x minus 4 is equal to plus or minus 2. Now we need to add that 4, so x is equal to 4 plus or minus 2. This is where we need to keep going. So x is equal to 4 plus 2, x is equal to 4 minus 2. So x equals 6, and x also equals positive 2. So 17 is kind of a special one where we actually get 2 solutions. All right, graphing quadratics. So here's our quadratic in standard form. First thing that I like to do when it's in standard form is find my c-value. C-value is the y-intercept. So positive 1 is going to be where we cross the y-intercept. After that, now I need to find the vertex. Remember, negative b over 2a is our vertex formula, or our x value of our vertex formula. So negative b would be negative 8 over 2 times 4 would be a. So negative 8 over positive 8, which gives us negative 1. So that's telling us right here at negative 1, we have an axis of symmetry. So now we can plug in negative 1 into the x values to find where our vertex actually is. So 4 times negative 1 squared plus 8 times negative 1 plus 1. So that's 4 minus 8 plus 1. 4 minus 8 is negative 4 plus 1, so that's negative 3. So now we have a point, negative 1, negative 3, that is our vertex. Now we can build across the axis of symmetry, so we have another point right here. Okay, and so as you can see, our a value is positive 4. So normally on a quadratic we would go right 1, up 1, but now we're going right 1, up 1, 2, 3, 4. Our second point in a quadratic would normally go right 2, up 4. 1, 2, 3, 4. So it would normally be here. So now we need to multiply that value by 4. So 4 multiplied by 4 is 16. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So a little far off the graph here to plot those last 2 points. So 14, 15, 16. I apologize for that. But now we have 5 points to graph. So we're going to go up like this, and then up like this. Okay? If you're struggling with the a value, what I recommend is just plugging in the next closest value to the vertex. In this case, we would plug in x equals 1, right? So if we plugged in x equals 1, it'd be 4 times 1 squared plus 8 times 1 plus 1. So that's 4 plus 8 plus 1, which is 13. So then we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we map across that axis of symmetry to the other 13. When talking about domain and range, domain, all of the possible x values. Well, we can plug in anything into this equation. So we would say all real numbers for the domain, right? Also, we can see that it's going to the right forever and the left forever based off of our arrows. For the range, we do have a lowest value. The lowest value in this case is negative 3. So we're going to say it goes down to negative 3, but then goes up to positive infinity. All right, next, graphing the quadratic in intercept form. So these are our intercepts. Intercepts are 1, 0, and negative 3, 0. So we're going to go 1, 0, negative 1, 2, 3, 0. Now we find the axis of symmetry. It's dead center of those 2 points. So those 2 points are 1, 2, 3, 4 away from each other. So 2 is right in the middle. So now we plug 2 into the equation. 2 times 2 minus 1 times 2 plus 3, which is 2 times 1 times 5, which gives us positive 10. Oh, whoops. Why did I say 2? We plugged in negative 1. We plugged in negative 1. So we plug in negative 1 into both of those things, and that gives us negative 2 times positive 2, which 2 times 2 times 2 is 8, so negative 8. So then we have a point at negative 1, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. Boom. Okay, following the last rule that we did with a value, right 1, up 1 is the normal spot where it should be, but our a value in this case is 2, so we're going to go right 1, up 2, left 1, up 2. So these would be our 2 other points we can graph, and then we just throw these in here, like this. Again, if you don't like using the a value, plug in the next closest number, which in this case is 0. So if we plugged in 0, we would have 2 times 0 minus 1 times 0 plus 3. So that's 2 times negative 1 times 3. 2 times negative 1 gives us negative 2 times 3, which is negative 6. So at 0, we should be at negative 6. 1, 2, 3, 4, 5, 6. And then graph the point across the axis of symmetry. Okay, domain always is all real numbers for any quadratic. Range, lowest value again, in this case is negative 8, so we're including it. And it's going all the way to positive infinity. So that's the review sheet. If you have any questions, please message me on Canvas. That's what I'm here for. I hope you guys are having a great day.